Okay, welcome back to Unit 6. This is our second lesson, and we're going to be starting factoring today. I know this says lesson number 7 at the top, but it's not. It's because of what's happening with COVID. We've had to reduce some of our units and just cover all overall expectations. So right now today we're doing something that's opposite to expanding. We're going to be starting factoring, and factoring is the most important stuff that you need to know for quadratics for this year and next year. So we're going to start with the first form of factoring. And factoring is basically going backwards from expanding. We're going to be creating brackets. We're going to be putting the brackets back in. Okay, so we're going to start with greatest common factor, which is pretty simple. All we need to do is find the biggest number and the biggest letter that can be taken out or divided out from all the terms that are inside the expression. You can't make anything a fraction, and you can't make anything into a decimal or have a negative leading term or anything like that. So really what we have to do is just trial and error here, and I'm going to teach you some tricks of the trade. So let's look at the first example here for factoring. What we've got is a 4x plus 20. And basically we want to take something away from this expression, take something outside and put it outside of the bracket and reduce the expression. When we take something out, we know that we're going to be dividing, because when we put something in, like we did in the last lesson, we were multiplying. So here's the trick. You're always going to be trying the smallest number, and then you're going to look for the smallest degree for the variable. And that's the one that comes out. So let's look. 4x plus 20. We'll do the numbers first. The smallest number between 4 and 20 is, of course, 4. And now we need to check. Does a 4 divide evenly into a 4? Of course, it's 1. Does a 4 divide evenly into a 20? What's 20 divided by 4? 5. Great. So that means right now the greatest coefficient, the greatest common factor that I can take out right now is a 4. But let's see if we can take out any letters. This first term has an x. The second term has nothing there. So I can't take away an x because the lowest amount is nothing. In other words, when we take something out, they all have to have it. All the terms have to have that variable that you're taking out, or that constant. So now, to rewrite this expression, 4 is being divided out. So we write 4 in the front. Now we're going to start putting back our brackets, and we're going to rewrite this expression inside our bracket, but divided by 4. So 4x divided by 4 is 1x. Plus 20 divided by 4 is 5. And you're done. That's our first form of factoring. Now, if I wanted to expand it, because remember, factoring is the opposite of expanding. If I wanted to expand it, which I don't, I would just do 4 times 1, which is 4x, 4 times 5, which is 20. Okay, let's look at another example. 5x plus 30x squared. So again, between 5 and 30, what's the smallest number? That's right, it's a 5. Does a 5 go evenly into a 5 and into a 30? Yes, it does. Now what we're going to choose is the smallest variable. This x is to the power of 1, and this x is to the power of 2. So which one of these is the smallest? Of course, the x to the power of 1. We don't need to write that 1 though. I'm just showing you of what's coming out, because they both have x's. It's just one of them has 2 and one of them has 1. Now, the greatest common factor is that 5x. Where does it go? Outside the bracket. And then we divide all of our expressions. 5 divided by 5 is 1. You used to have 1x, and you took 1x away. Do you have any more x's? Nope, they're gone. Where's that other x? On the outside of the bracket. Plus 30 divided by 5. You used to have 2 x's. You took one of them away. So you've got 1 x left. You're done. Let's look at another one. 12x squared and 48x. The smallest number between 12 and 48 is 12. Does it divide evenly into a 48 though? Check. Do 48 divided by 12. Is it a whole number? Yeah, it's 4. You have 2x's and 1x. I can take away 1x because 1x is my lowest. It's kind of confusing that we call it the greatest common factor because students might think it's going to be the biggest number, but it's the biggest variable and coefficient that can evenly be divided out of all terms. Okay? So I'm going to write the 12x in the front. This is my greatest common factor, and then we'll start dividing. 12 divided by 12, 1. You used to have 2x's, you took 1 away, that means you're left with 1x. 48 divided by 12 is 4. You used to have 1x, you took the 1x away, there's no more x's. Next. 21 and 49. So let's see. 21x squared minus 49x squared. You want to, I guess, because you're in this mode right now, like we want to take out, we want to try a 21, right? And we want to take out 2x squares. But do you notice something weird about this? Yeah, they're like terms. This is an x squared and this is an x squared. So really, they can be put together. And if we put 21 minus 49 together, we get negative 28. And when we collect like terms, do we ever change the degree of the variable? Never. We put our x's together, they still stay as an x. So we still have that x squared. Can you greatest common factor from a monomial? No, it's just not possible because it's only one term. So you have to have a polynomial there. You have to have more than 2 terms to be able to take something away from. This is just a monomial. So that was put there as a trick. Let's keep going. 12, x to the power of 5 and 3. So the smallest number there is 3. We have 5 x's with the first one. Do we have any x's with that 3? No. So can we take away any x's? No. All we could take away is that 3. So 12 divided by 3 is 4. There's still those 5 x's. And 3 divided by 3 is 1. Let's look at another one here. Let's get into something a little bit bigger, like a trinomial here. So 2, 12, and 30. We'll try the 2. Does it evenly go into? Yep. We've got 2 x's, 1 x, and no x. No x is our lowest x, so we can't take out any x's. So we'll be left with the 2 on the outside. 2 divided by 2 is 1. 12 divided by 2 is 6. 30 divided by 2 is 15. And you're done. Next one over here. Now, here's another little rule that we got to review. You see this negative sign that's in the front here? It's saying right now there cannot be a negative as a leading term. So whenever we see a negative sign, we're going to say that that's not allowed. And we're going to take out a negative number, even if it's a negative 1, no matter what. So now we're going to try between 15 and 20. We're going to try to take out the 15. Does a 15 divide evenly into that 20 to produce a whole number? No, it doesn't. So you might stop there and say we're done. But no, we got to try other numbers that can go into that 15 and into that 20. So if I look at my multiplication table, what else goes into a 15? The next greatest number is a 5. Does a 5 evenly go into a 15 and into a 20? Yeah. So then I'm going to take out a 5, a negative 5, and now let's look at my variables. 1x, no x. So I'm going to take out just the negative 5 because that's all that can come out. You can't take out any x's because that 20 doesn't have it. Negative 15 divided by negative 5 is positive 3 with the x because we didn't take anything away. Negative 20 divided by negative 5 is positive 4. So you can see we're using the same premises, but we're getting a little bit trickier and we're adding different restrictions or rules as we go on. Let's look at 2 more here. 4, 20, 16, and 8. The smallest number is a 4. Does it divide evenly into all the terms? Yes, it does. 5 x's, 3 x's, 2 x's, 1 x. The lowest x is 1, so we'll take it out. We write that 4x on the front, put our bracket, And then we'll just go through each of the terms. 4 divided by 4, 1. 5x's take away 1, 4x's. 20 divided by 4, 3x's minus 1. 16 divided by 4, 2x's take away 1. 8 divided by 4, 1x take away 1. Okay, let's do one more here. 20, 15, and 30. So this is pretty much as hard as it's going to get, right? Because if I look at the numbers, 20, 15, and 30, the lowest number is 15. 15 does go into 30, does go into 15, but doesn't go into 20. So now you have to look at the 15 and say, what else goes into the 15? And we already did this one. A 5. So then a 5 is going to be, let's see, does it also go into a 20 and a 30? Yeah. So that is going to be, right now, the biggest letter that I can take, or sorry, biggest coefficient that I can take out, number. So now I'm going to look at the letters, the variables. 1x, no x, 2x's. So can you take away an x? Absolutely not, because there's no x with that 15. Can't give you any x's. 1y, 1y, 1y. They all have a y. So then I am going to take out a 5y. Now we'll divide. 20 divided by 5 is 4. You used to have a y there. Now you're just left with an x. 15 divided by 5, 3. You used to have a y, you took it away, so there's nothing else there. Negative 30 divided by 5 is negative 6. You have 2 x's and no more y's. And that's about as hard as we're going to go with greatest common factor.